All right, can I get some brave soul sitting in the back row to tell me the derivative of the numerator, please? Oh, goodness. Somebody in the back row would be brave. You're not in the back row. Somebody be brave in the back row. Just the numerator. Yeah.
4x plus 4.
Thank you. I think what I'm also going to do is call it this. Why might, one second, ladies, please. Why might it be useful to write it as 4 bracket x plus 1 if you look at this question? There's going to be an x plus 1 in the bottom, so that may be helpful to us later on, okay? All right, can someone in the middle row take the derivative of x plus 1 for me, please? Not all at once. What's the derivative of x plus 1? 1, thank you, good. Okay, if you are expecting for a laid back lesson today, don't be you. Everyone will be called on today. Please get in the zone. We got a lot of awesome word problems to do, okay? So I need you guys awake and at it here. Okay, so can someone be brave and mash that all together for me? Someone from the front row. F prime of x equal to what? Oh, not all at once. Go on, please. Yes.
4x plus 1 squared.
Good.
And then minus 2x squared plus 4x minus 1 brackets.
Whoa, goodness, what happened? Sorry, no mistake there. Sorry, 4x plus 1 squared. I missed the last part.
Yep. And then minus bracket 2x squared plus 4x minus 1 bracket.
Okay.
Over x plus 2 squared.
X plus 1 squared, lovely. Okay, excellent. Okay, why did Laurel make it x plus 1 squared? X plus 1 and x plus 1, okay? So far so good? Now, on the test, a lot of people tried to take the second derivative based on this. What might it be useful to do before I take the second derivative? Yeah, I'm totally foiling that out. I have to, okay, because that's a horrible mess. Benny, since your mother drove by without even waving today at the school. Okay, can you please foil out the numerator, please? Go ahead.
Like with the minus in as well.
Yeah, let's do this part first. Go ahead, the left-hand side.
So 4x squared
Yeah,
plus 8x
good.
plus 4.
Yeah. Okay, so if you look what I did there, right, I just folded, and I changed the sign of everything on the right-hand side. So we got f prime of x equals 2x squared minus 4x plus 3 all over x plus 1 squared. Okay, can I get everyone to please close their eyes for 1 sec? Oh, question, go ahead. Whoa, 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 whoa. Thank you, Shelby. Okay, can everyone please close your eyes for a sec? Who got that with, oh sorry, Amy, 1 sec before you close your eyes. Amy, go. Oh, goodness, Mr. Sadler. All right, finally, any other, before I get you guys to close your eyes, any other complaints here? We're good? We're good? Can you close your eyes now? Who got that with no help from Mr. Sadler? Okay, thank you for correcting me. That's lovely, okay? If you need support on this, this is one thing you need to work on. Quotient law and product rule will be used throughout this course, like from here on out. Like if something like that was a standalone the last unit, like it's coming up heavy duty the whole rest of the way through. Okay, second derivative, I'm going to strongly recommend using this form, because this is very much like our original equation, unlike this, which is a mess, okay? Can someone now from the, we're in the middle row? Click on the middle row. Can someone in the middle row do the derivative of the, I'm going to do this as the new, that's not really what it's called, but I'm going to go with it. What's the derivative of the numerator? Go ahead, please, someone in the middle row. Yeah, go ahead. Wow, that's funny. Which I'm going to conveniently call 4 bracket x plus 1 again. That's cool for you guys? Sound good? Okay, can someone in the back row, sorry back row, you guys are getting destroyed here. It's time to speak up. Someone in the back row. What's the derivative of the denominator? Nate, go.
2x plus 1.
Good. So H, I'll call that h prime of x. It's not really, but I think you know what I'm trying to do here. Okay? Okay, now the reason it changes to that is because we had to chain it, right? So I called the 2 came down, the x plus 1, the bracket stays the same, right? And the derivative of the bracket is just gonna be 1, so nothing's gonna change. Are we feeling somewhat good on that? Most people? Jeff, how you doing?
Isn't that the second one?
Yeah, technically. It's not, I don't really want to, yes, but yeah, okay. All right, can someone from the front row mush it all together for me? Okay, can someone please from the front row mush it all together for me? Thank you. Okay, hold on a second, 2 times. Okay, go ahead. Okay, good. Second. Divided by what, sir? Divided by x plus 1 to 4.
Yeah, there's a 2x plus 1 up there.
2 times x
The h of x.
I'm here. You know, I think I'm not, but I'm actually here. Are we better now? Okay, so what I did there, and hopefully we're okay on this, Jeff, is what we did, quotient rule there again, and chain and all that stuff. Now, this is another thing that people struggled with on their last test, is the common factoring. Can someone from the middle row, Jeff, tell me what's common in the numerator, please?
X plus 1.
No.
Yeah.
Yeah, it is. X plus 1, you get 2.
Good. What else?
You get a 2, guys.
You should.
Well, it all cancels out later on.
Yes. Play along, please.
Beside that, it's a 2 in front of the x plus 1 squared.
See this? Okay, can I just, I'm gonna hit pause for a second. And first of all, I'll tell you guys off. You guys are wonderful. And you can see why I have difficulty recording these lessons without you. You can see that, right, where I make mistakes all the time. Because I'm just talking to myself going to town, and you can see where I drop numbers. I apologize about that for any future video lessons that I will have. Okay, so we understood where the common factors came out, mostly? Okay, back row, I'm gonna snub you this time since there's only 4 of you. Can someone from the front FOIL out, simplify the numerator, please? What's it gonna turn into? Someone from the front row. Arden? Can you FOIL this out, please?
Sure.
FOIL this.
2x squared plus 4x plus 2 minus 2x squared minus 4x minus 5.
Thank you. So that was just foiled out. Good. Can someone from the middle row be brave, please, other than Jeff? And what is this bracket all going to turn into? What does that all cancel out to be? Evan, what does that turn into? -3. And the x plus 1 is going to cancel. So I'm just going to leave that as -6 if that's okay. Can I go right to -6? Are people okay if I skip that? Okay. All over x plus 1 cubed. And that's f double prime x. All right. Questions, fears, and comments. Please be brave. Okay, you'll have to do this on your test. I think I'm probably going to have 4 questions on your test. And I should pause before I say this, because I had a former student complain about this. So those are my 2 derivatives. Are there any major questions on where those came from? Okay, so let's do the actual calculus graphing here right now. Where did I stop? Who picked this? Who was that, Joe? Who did that? Arden? Who did that? No, it was Evan who did that. Okay, can I pick someone from the back, maybe that hasn't said anything yet? When I graph with calculus, Liam, what's the first step to graphing with calculus, please? No, the way Mr. Wood, you can think back to the way Mr. Lacey did it too. Remember the first thing? I think it was the D. Go ahead. Domain comes first. Okay, back to my original function. Now, you guys have a little easier time graphing this than I do because I'm over 3 pages here. What for the domain is we're just dealing with restrictions on x in the denominator. So it divided by x plus 1 is what it was, I think, right? So we're going to say my domain is going to be all values of x such that x cannot equal -1 xer. And if your grade advanced functions teach you the domain a different way, that's fine, as long as I can make it what it is. Open brackets, closed brackets, all that stuff. I can live with all that, okay, as long as I can make it what it says. Okay, can someone from the front row either flip to their notes or use their memory? What's the next thing I do after domain, please? Someone in the front. Sorry? Y-intercept, okay? Now, probably, guys, try please do this, okay? If you retake calculus next year, and Mr. Lacey is doing it, he also does x-intercepts for these, but it's a lot of work for not much result, okay? So what's my y-intercept going to be? Going back to my original equation here. Something from the front. Yeah, so you have a -1 here and a -1 there, so it's just going to be -1. 0 and -1. Okay, are most people okay with where that came from? I hope at calculus we're good at y-intercepts. Good. Okay, can someone in the second row tell me what comes next? You're not in the second row, but thank you anyway. Okay, good. What type of asymptote is this going to be? And even though I sort of mixed up Tuesday's lesson, hopefully I was clear about this first. What type of asymptote is this going to be and why? Come on, guys, please play along. Please play along. Yes. Oblique for why? Good. Okay. So this is an oblique for sure. Yes, you can use synthetic if you want to. I will use long division either way, so you can do it as quickly as you can. I'm going to not ask for volunteers, so I'm just going to long divide here. If you want a synthetic, go ahead. So I'm going to have x plus 1 into 2x squared plus 4x plus 1. I shouldn't groan, I don't mean to groan. It's just because I think of myself making this video for myself whenever it's going to happen again, and I'm going to mess up the entire thing. All right, so I'm going to start with here, I'm going to say that 2x goes into this. Okay, so that changes into 2x squared plus 2x. You subtract that out, that turns to 2x minus 1, and that turns into plus 2. And that's a 2x plus 1. Oops. And that's a minus 3 remainder. A minus 3 remainder is okay. What that means is that the graph is going to come close to 2x plus 2, but not quite hit it. So my asymptote is going to be y cannot equal 2x plus 2. Okay, are we sort of okay about what's happened so far? Okay. What I'm going to do at this stage is I'm going to refer to Harry's beautiful graphs, and I'm going to encourage him and everyone else to take out the graph paper right now and draw the asymptotes in. Okay, because the asymptotes are generally the easiest parts to get into, so I'm going to draw this. As a reminder for 2x plus 2 going back to grade 9, again, your y-intercept is going to be at 2, right? And then you're going to have over 1 up 2 is sort of how it's going to go. All right.
My last piece of graph.
Your last piece of graph, we've been one graph the entire year, Harry. And on your last piece?
I don't know where they went.
Oh. How many graphs have you done this year? Like 3 graphs at the moment. I'm
We've
sorry,
only finished
Harry.
1, I think.
Harry, I didn't mean to get upset with you. I apologize. I'm just concerned that you
I'm
read
not
a
Sadler
graph
Garden
paper.
for stealing them.
I blame Matt, considering he skips math
Yeah,
classes.
it's probably bad. Laying low for a few days at the big hike.
Okay, so here we go. So here's my graph. I have 2x plus 2, so I'm going to put my graph a little bit below here, I think. And sort of like this. I'm just sort of estimating where this is going to go.
Like a little square like that, and it's like graph inside of
Did I ever tell, I showed you guys last year, I got for the OAME math conference, I got sticky notes that were graph paper. It was very awesome, it was a little tiny sticky, that, yeah, I think I probably have it if I look hard enough, but I have to teach right now. Y can, well, 1 was our first one, right? Was that right?
Yep.
X can equal 1, I mean?
X can equal
See, aren't you guys, I'm so glad you guys are here. You know how many mistakes I've made? You can teach the course next year, I think, Bill or Elle, it'll be better there. I'm joking, but thank you very much, because this would cause people a great deal of
No,
headache.
it took me that long to check this.
Okay, so then as far as 2x plus 2, here we go. There's 0 and 2. I'm going to go up 2, right 1. Sort of like this.
Is it very nice?
Yes, it is.
Yeah.
Is that right? I think that's right. Okay, does that look good to you guys, mostly? That looks good for you guys? Okay. So the way the graph's probably going to look, it's hard to say, but if I had to guess, it's either going to look like this and this, or like this and this. Those are my basically two options there. Okay, we got that? All right? Okay, so we're going to make our interval chart right now. Okay, we're going to do critical points. So if I was doing this on my test, I'd take the derivative now, but we actually have to look at the critical points. So can someone remind me, I'll open this up to anyone here. What are my critical points I have to look for on the graph? What are sort of the intervals that I'm going to use here? Sorry? Good? Oh, what's, somebody help here? What's it going to be, please? Uh-oh.
F of x, when f prime equals 0.
Good. So my critical points are going to be these points. And this is what I wasn't clear about on Tuesday. It's when f prime of x equals 0, f double prime of x equals 0, or, and this is the new part, an asymptote. Okay, because weird things happen at asymptotes, always. Okay, yeah, tangents and, and all sorts of things, and if you think of all these, how they're going to work. So I'm going to try and solve all my equations and see if I can get any critical points. Looking back at my equations, because I'm going to read them out to you because I don't have them here. What was f prime of x equal to?
2x squared plus 4x plus 5 or x plus 1.
And f double prime of x is? Which is -8, you said? Okay, let's start with this one first of all. For f double prime, okay guys, could you please do this? Stay with me here, please. For f double prime of x, is that ever going to equal 0?
No,
Pourquoi?
because there's always a 6 on top.
There's going to be a number in the numerator. Okay, right? So it's impossible to have that number equal to 0. So here there's never, f prime of x can never equal 0, right? Ever. This one might work a little bit better. Okay, if I do b squared minus 4ac, 4 times 4 is 16, minus 4ac, we're going to say that, is that right, is less than 0? Right, discriminant, you guys are all aware of discriminant if I say that? Okay, therefore, no critical points.
I think I missed this. Why isn't y sitting next to
It will be. This, okay, so this, and it will be. But this is, sorry, this is the, this is an asymptote then, right, okay? Okay, so there's no critical points. Weird. Like wacky even. Wild, I'll even say. We still have to make an interval chart. What's our only interval that we're going to use?
Yeah.
The asymptote, okay? So all we're going to have for our interval chart is, and this is going to be a nice small one, x is less than -1, x cannot equal -1, and x is greater than -1. That's it. Okay?
You don't have to.
Okay? So everyone see that? Okay? This is going to be nothing. Nothing actually happens here. Okay? Because there's no points that x can't equal -1. But different things will happen on either side of the asymptote. Okay? Okay, so for x is less than -1. So let's pick my favorite number less than -1 is going to be -2. Okay? I like -2. -2 squared is going to be 4. 4 times 2 is 8. -2 times 4 is -8. That's lovely. That cancels out beautifully, so the numerator is 5, so we're good. And -2 plus 1 squared is -1 squared, that's a positive. It looks to me like that's going to be positive. Does anyone want to argue that point with me? Michael, have you checked that for accuracy? Uh-oh.
That column, it looks like it's saying fx.
Yeah.
I will do one thing right
The
eventually.
little times.
I was-
Close.
This morning I was doing a triangle X, Y, Z, and my whole grade 10 class started said X, Y, 2, the entire class. So I have to work a little later. Okay, you don't laugh, Harry, it's pathetic, but it's true. Okay, for f double prime of x, I have negative x over x plus 1 cubed. If I have x is negative 2, okay, what is negative 2 plus 1 cubed is what? Negative. So what's a negative divided by negative? Positive. So what does a positive slope that is getting more positive look like? Sort of like this. So as far as what the graph's going to look like, it to me is going to look something like this. It's going to slide along the oblique asymptote over there, okay, and then head on up the x. Yeah, go ahead.
Should we also figure out whether it's on these sides or these sides of length?
You could, yes, you could. Like, yeah, that definitely be one. Probably on your test,
On this.
I may give you one with two asymptotes here that'll work out nicely. Okay, but yes, you definitely could, because this is going to be your point here for sure. Okay, but yeah, that would, yes, in this case, yeah, that would work the same way. So in this case, we should hopefully have, looking at it, I'm hoping we have a positive slope that's getting more negative. That's what I'm hoping for.
So how do you know it's on the left side of that?
Okay, because it says your x is less than negative 1, right?
Oh, okay.
So, and it's possible to get a positive slope, it's going to hit the asymptote, right? Okay. All right.
So if you're thinking about it, if it was in that top section, that bottom section there, it would have a local max or min.
Right, good point, yeah. If you, good point here, Michael. So if the graph was here, you're right, there'd have to be a local max somewhere over here. The same thing, if it was up like this, there'd have to be a local min somewhere over here as well. Yeah, good point, Mike. All right, as far as x is greater than 1, my favorite number greater than 1 is going to be 0, okay? Excuse me. So 0, 0, 0 all cancels out, so that's a positive. 0 plus 1 is a positive, which makes this positive. Negative 6 is a negative, 0 plus 1 is a positive, so that makes that a negative. So it's going to look something like this, which is nice. So my graph then is going to look something like this. Yeah. And this one looks a lot like the question in the note, right? This in the, if you take a look at the example I did, this looks a lot like this one. Okay. Somewhat helpful, more helpful than Tuesday's lesson was, I hope? Yes. Okay, good. Let's go and hit pause and we'll get on to word problems for the rest of this unit, okay? If there's questions, you can raise your hand and Mike will hopefully